welcome to the Planning for Active Distribution System session. So just a quick introduction on myself. This is Alessio Coccia, Engineer 1 from the EPRI side in the Distribution Operations and Planning team. And we are glad to have you all here for this presentation. So just a quick introduction on what's this session based on, what we will discuss about. So it's just a session that we will find out how the accommodation of the new resources could affect the grid, and we'll try to give an overview on potential solutions to integrate these resources. Just to remind you that this is a workshop, so please do introduce yourself in the chat, in the WebEx chat, do ask questions, and yeah, just try to get involved into the conversation with the speakers. So this is the main agenda that we will cover today. We'll start the session with Fiona O'Donnell. Fiona is a power system requirements manager, actually involved in the National Network Local Connection Program in the ESB networks in Ireland. She will give an overview on the adapting planning methods for an active distribution systems in Ireland. This presentation will be followed by Matthew Rylander, project manager principal in EPRI in the Distribution Operations and Planning Program. He will present the developing planning tools to address active distributed energy resources. Then Frank Borchardt, sorry for the pronunciation of your name, from FNN, will present smart operations for future grids that will touch on flexibility in the distribution networks and e-mobility. Then we will be split up into different breakout sessions into 4 rooms, in which there will be 4 EPRI members that will act as moderators. We will present you 4 questions, so it will be an open discussion. So I just kindly invite you to unmute yourself to participate in this open discussion, try to answer this question, and the moderators will write down the main ideas and the main outcomes that will be found out during this session. And then Mario Couto, technical leader in the Distribution Operations and Planning team, will present the upcoming opportunities for collaboration in Europe. And finally, I will end the presentation. So just another suggestion before asking question to the speakers, just ask to on the WebEx chat as I did. Present yourself before, and then do ask questions to them, and speakers will then reply to them through the WebEx chat. So I make you new presenter, Matthew, so you can manage the Fiona's slides. Before your presentation, just do introduce yourself, introduction of what you do and your role in your company, and then just start your presentation. So the floor is yours.
Thanks very much, Alicia. As noted, I work in ESB networks in Ireland. As Alicia said, I'm currently in a relatively new program, which is National Networks Local Connections. And it's really us in ESB networks kind of starting out on our journey for having active distribution systems. Program is in place about a year now, and we're starting to run some pilots. At that stage, my background before that, I spent quite a bit of time as a planning engineer, power system planning engineer, and I also spent time in regulation, which was very focused in the kind of 2000 to 2010 on the introduction of renewable generation to the distribution system. Do you want to flick on our map, please, to probably slide 2 or the next slide, please? Okay, so the slide you see now kind of sets out the challenge, and the challenge really has been set by EU legislation and by Ireland's response and ESB's response to that legislation as to how to reduce our impact on the climate. Our task has been to try and make sure that the utility is not a barrier to that challenge, but obviously, as with all utilities, to do it in a cost-effective manner. So if you look at the numbers, we're aiming to be able to accommodate 1 million EVs charging on a regular basis in the country. Now, to put that in context, that's around about 1 EV in every 2 houses. And currently, as of the end of 2021, I think the count was somewhere between 45,000 and 50,000 EVs currently running. So there's quite a bit to go before we can reach that number. We're aiming to have about 600,000 homes being heated via heat pumps. At the moment, we have very little electric heating in Ireland. We have a lot of gas, we have oil, but very little electric. We do have growing numbers of houses who are installing solar panels on their roofs, and our building regulations have been changed in recent years to encourage that even further. So I think we will see quite a lot of that. And we're planning to have about 5 gigawatts of additional generation onto the distribution system, which is probably, I think it's about twice as much as we've installed in the last 20 to 30 years. So that's a huge challenge as well, and will require us to change how we do business. So obviously, we're looking to accommodate all that stuff, but because people are going to be more reliant in the future on electricity, it's even more important that we do it in a way that ensures that we have a secure supply for all of those customers. Okay, do you want to click on, Matt? Okay, so there's 3 main arms to how we did this, with the centre core as well, which is the guy with the glasses in the middle, who's my colleague Connor, who's on the line. So the very first step was obviously to try and come up with an estimate as to how load will grow, and in particular, because we're talking about the lower voltage systems, where all the electrification of heat and transport is largely going to happen, where the load was going to grow. So Connor did a lot of work with our local, our government agency, which is the Sustainable Energy Authority of Ireland, and also with some of the renewable energy groups, for example, Wind Energy Ireland and the solar group ICA as well, to try and come up with a best estimate as to where the excuse me, the LCT technology and the generation was likely to turn up, if you like, on the system. And then he developed a number of different scenarios. Maybe one scenario is, okay, there's going to be an awful lot of EVs in rural, because people still consider, I think, the EVs as being more local cars, even though the range obviously has hugely improved from what it was 5 or 10 years ago. Another one was to sort of say, well, the more people see these EVs around, the more likely they are to get interested in and purchase one. So, I call it the kind of follower effect. If you see a couple of cars coming in your neighborhood, then you're going to start asking questions, you're going to start talking to people, and it may well develop. So that scenario was based on looking where EVs currently are and putting a more of a focus that there'll be more EVs in those areas. The 3 streams then that we were using to analyze that data, our kind of core traditional technical stream was undertaken by our own engineering and major projects organization in ESB, and they are continuing their work. They're still working on traditional load flows using PSS SynCal, and they did a lot, mainly last year, did studies on the MV system, and they're now moving up to the 38 kV system. We also have some 110, which is primarily in Dublin, which was studied last year as well. So that's our kind of traditional arm. Lots and lots and lots of data coming out of that, lots of results, and really good stuff, but very, very detailed. But we also said, look, we'll take a different look at it, and we went again to our own data analytics business unit in ESB, and we gave them the raw data and a couple of years of stories and said, look, go see what you can do with this. And they came back again with really good stuff. The level of accuracy in terms of voltage in particular, isn't the same as you would get with low flow analysis. But anywhere where the issues are primarily thermal and capacity issues, we got really good results. And where we compared the results to the work that we were getting from ENMP, there was a reasonably good correlation. So the third part, which is what Matt is going to talk to a little bit after this as well, is the work that we did with EPRI, which used both load flows and data analytics. Do you want to flick on to the next slide, Matt, please? So basically, EPRI were using the drive tool, which a lot of you are probably familiar with. So we were very keen, I suppose, to see how this tool was working and what the results are coming out of it. But the other advantage to us of working with EPRI is we were getting another perspective on the work we were doing and the problems we were facing. And we had lots of interesting Friday afternoon discussions as a result, which were very useful and very enjoyable as well, which is always good. So my perspective on the drive tool, and as an ex-planner, I was always studying for congestion, where the problems are arising. And when anybody asked, well, how much can I connect there? I'd always say, oh, that's a very hard question. It always was a hard question, but the drive tool seems to crack that one, which is great. So in terms of the work done, around about 100 MV circuits in Arklow and Escorthy, which is in the southeast of the country, near where I'm from. But probably the most significant piece for me, because again it was very new and it's something that we're really focused on, is the analysis of the load profile data that we had. So one of our key things, I suppose, is to see how we can see the impact of shifting load, especially where you have people installing or charging their electric vehicles. So obviously, if you can get people to shift load, it'll be better. But the question is, do you end up just shifting the peak, and to what extent is it better? So EPRI were able to give us some key evidence, if you like, based on the information and the load data we had, and our projections in terms of where the EVs might arise. That gave us some answers to those questions. That's the next slide, I'd say, Matt. Which is the last slide. So I'm not sure how clear that screenshot is for yourselves. But effectively what you can see, I suppose, on the columns on the right-hand side of the screen, our worst case is, well, what happens if these guys plug in their cars and have all their EV or have all their heat pumps running all of the time, and in particular at peak. And then the next column is uncontrolled, but we're prepared to accept that sometimes things might go wrong. So that's the risk part, the 20% risk part. ESP traditionally is quite conservative. By virtue of us moving to active management, we're going to have to take a step away from that. By the nature of it, there's the huge advantage, I suppose, to moving to more actively managing, that is that you can be less conservative. That'll be interesting when we present that to our senior managers as to how that'll all work out. But the middle column is kind of an acknowledgement of that, is that we might be prepared to take a risk if it means that we can accommodate people without doing significant reinforcement on the system. The last column on the right, which is the one I like the best, I guess, is the ones where we control and we say, well, you're allowed to charge between 0 and 5 a.m., for example, and we're also prepared to take a little bit of risk. And more in more recent times, probably only really the last year or 18 months even, suppliers in Ireland have started to more actively take advantage of our smart meter installation program, which is still ongoing, and they started to offer time-based tariffs. One of the tariffs offered by the suppliers is actually a charging. It's focused at EV owners, but it's using electricity between 2 and 4 in the morning, means you get your electricity for a quarter of the price. Now, that's obviously good in a lot of ways. As a distribution system operator, that potentially could end up being very bad for the local network. So ultimately, where we hope to go is to move to more signal-based charging. So instead of saying every night is going to be 2 and 4, it's, well, you know something, we'll let you know what's good on a particular day and a particular night. And a lot of that could be well linked into when is the wind blowing, when is the sun shining, in your area to make best use of the renewables. So as I said, the work that EPRI did give us a good view of how that can be, how the time limiting of these resources, which definitely EVs are definitely flexible, can be of huge benefit and can mean that we can accommodate with stuff without doing a lot of network reinforcement. That's probably just a potted history. I think I'm okay still in with time, so I can hand over directly to Matt. Thank you.
Yeah, I appreciate that. Thanks, Fiona. So that's a good segue into my following presentation. And my name's Matt Rylander. I'm from the Electric Power Research Institute, and we were working directly with Fiona on that particular project. So the project that Fiona was mentioning there had two components. One was more of a detailed analysis using traditional tools, and then what we were trying to do that Fiona mentioned there, using the EPRI Drive tool, doing something new with a new tool that's really focused on wide area distribution assessments, looking across the grid and the impacts of these new resources from more of a holistic point of view. So my presentation here from the Distribution Operations and Planning group at EPRI is really focused on developing new tools to address active DER. And this particular tool in my presentation today will really be focusing on that drive tool and how we were using it in the project that Fiona was mentioning to assess, well, if we were able to control these DER, and these DER that we're talking about here are really electric vehicles, heat pumps, controllable loads, but they could also be DER such as photovoltaics, different types of generation as well. But strictly speaking here was those electric vehicles, if we could control them to be more active, and could we make them charge when we need them to, how could that change our ability to accommodate those devices? So in my presentation today, I'm going to focus on really giving you that perspective of tools to do more holistic wide area distribution assessments. You know, what we're working on here at EPRI and really can be applicable from a planning and also operational standpoint. As a takeaway from my part of the presentation today, this workshop week, is really for you to just have the ability to be enlightened of there are new capabilities, new opportunities to look at the grid and look at these assessments in a different way. And provide any feedback, use the chat. You know, if I don't get to it during my presentation right now, I'll be looking at the chat as we go through the rest of the session today and can provide any responses back there. So please take some of this new types of analytics and kind of digest it and let me know what you think. So, you know, the motivation, as Fiona was mentioning there, was to understand how this significant amount of electric vehicle and heat pump growth across the entire distribution grid would affect you know, the grid itself, and what type of proactive approaches do we need to do now to prepare ourselves for, you know, these coming years. And this particular project was focused on a 10-year horizon. So we saw that there's a lot of growth across the entire grid. How are we going to be able to accommodate that over the next 10 years? What feeders are going to be impacted? And take it with a grain of salt. I call feeders, they're radial networks, which might be more common terminology that I should use, but I'll call them feeders nonetheless. And how are we going to build out those feeders? How are we going to reinforce those radial networks to accommodate this growth, this significant growth? And there's a combination of solutions. One of them was to look across maybe this active management or active control of devices. And to address that, we were utilizing these new procedures to do time series hosting capacity, where we'd be able to see how does the ability to accommodate these resources change over time. There's also these solutions such as just grid reinforcement and mitigation that we're applying through this study and through these WADA assessments. But my primary focus today is going to be really on that time series hosting capacity. You know, being able to actively manage these devices or control these devices to be able to integrate them without any grid or with minimal grid impact at this point. So that's kind of where we're starting from. We were doing it one way. You could do it detailed assessment another way, but we wanted to look at more efficient processes to do this assessment, to look across the entire breadth of the distribution grid and give some response back of what feeders are impacted, what feeders could potentially accommodate plenty if we just had a little bit of active control of those devices. So there are the several parts of this assessment, and I'm going to walk through several different pieces of this assessment, but it all starts with the distributed hosting capacity. And when I talk about distributed hosting capacity, I'm looking at about distributed growth across the grid. So every radial network is going to have some forecasted deployment of new resources, and it's going to grow over this next 10-year horizon. But how much of each one, how much penetration can each one of these radial networks accommodate? We can assess that through a WADA distributed hosting capacity analysis. And the image here on the right-hand side illustrates that these darker shades are going to be radial networks that are going to be limited to how much new growth can be accommodated in this 10-year horizon. The shades that are bluer are the feeders or the radial networks that it can accommodate quite a bit. And we wanted to identify, well, when will each one of these radial networks start to see some problem occur? And that gets back to knowing what the growth is. It could be a propensity type forecast of how much distributed growth is going to be across these different areas over the next 10 years. Before I get into the growth aspect, I really just want to highlight more on the hosting capacity analysis. And the terminology might be a little bit vague, but there's different ways to do hosting capacity. The way that we are really utilizing it here is not from a generation aspect. We're looking at hosting capacity by how much load can be accommodated. So in most common uses of hosting capacity, you think of, well, how much more generation could I have before a problem occurs? But in this use, we're looking at, well, how much more load growth can we have before a problem occurs? And it's not focused on single point connection locations. It's looking about a scattered growth of devices across a feeder and how much can that grow until we see a problem occur. So, you know, hosting capacity is really an evolving area of analytics where you can do it many different ways. You can do it with many different impact factors and take into consideration many different metrics by which define hosting capacity itself. But in this particular use case, we're seeing, well, how much more load growth across an area can we accommodate before something breaks? And that's really powerful for this type of study. So when we do this type of hosting capacity assessment, we can see, well, when is that worst case? When is that first thing going to break on a feeder? And in this example that I have on this screen, we're seeing that we might have our first thermal violation at only 0.2 megawatts. And if that were to be taken into consideration, well, we have this load growth across the next 10-year horizon, and we see that here in year zero, we're already potentially at a violation point. And that's a concern. You know, if we're doing worst case analysis, this feeder is not going to be able to accommodate much. And we're already beginning to be concerned with this particular feeder. But as you can see in the left-hand slide, there's the left-hand figure, there is a lot of time variability on how much we can accommodate over a course of a year. So the left-hand figure shows hosting capacity over the duration of a year. And many times in the summer months, you know, there might be much more hosting capacity when the load is a little bit lighter. And that's all going to be taken into consideration here in 2 slides from now. But right now, I just want to focus on doing that wide area assessment to identify that worst case scenario is really powerful to see, well, when do feeders start to be potentially in a problem standpoint. And we can do this wide area type assessment and quickly understand that over the next 10 years, we're going to see quite a few feeders start to have these potential violations. Year 0, 2021, not many feeders. The example I showed in the previous slide was that one feeder was potentially problematic, but then it increases over the next 10 years as that growth really starts to accelerate that we have forecasted out there. And these are all feeders that we need to start thinking about, well, what do we do now to prepare the grid in the future of, to accommodate this growth? And there's a lot of grid reinforcement that could be needed. 20 to 25% of the feeders needing some significant grid reinforcement, and that's something that needs to be taken care of. And something needs to be done. But part of the assessment here for the active loads is to understand, well, maybe it's not just about grid reinforcements. Maybe it's about the control of these devices that I need to focus on. And one of the aspects of getting into this time-based analysis and time-based hosting capacity is to identify that our ability to accommodate is really variable across the year. And that's because load changes on the feeder, generation changes, operationally, things change across the feeders during the course of the year. So there's two aspects that the time-based hosting capacity really provides us a glance into. One is that these worst case conditions only happen for a limited time of the year sometimes. So in the set of figures that I have on the slide, in the upper right-hand side, you can see that if you just look from a risk point of view, that worst case scenario that sometimes we plan to might be very uncommon. And that's something that Fiona showed, this 20%. 20% was just taken as a random number that we work towards, but it might just be, let's assume that the 1 to 2% of the year might not actually happen. So if the 1 or 2% of the year that might not happen is excluded, our hosting capacity by itself might go up considerably. That's one thing to consider. But the real nugget here is to consider that just a little bit of control, being able to actively manage these devices, can have a lot of benefit. And that's what this lower figure shows in the slide, that if you were just able to give some customer incentive or the ability to understand that we just can't control, in the middle of the day towards we can't charge these new electric vehicles in the middle of the day towards early evening. If we're able to control them into the night hours and utilize the grid at that point, we could get a lot more utilization of the grid. We could really be able to take advantage that we can provide the energy to charge these vehicles if those vehicles were just charging at the right time. So that's where this time-based hosting capacity really came into play for our point of view. We could look across the grid and observe that we have the capabilities to really utilize the grid at these certain points in time. And getting back to the slide that Fiona was showing earlier, and I'll talk to it too, just your worst case planning analysis might identify, and here I've just pulled out about the top 10 to 20 feeders that had the worst case impacts. You might have feeders that have very significant limitations, not much hosting capacity at all, but by utilizing either a risk aspect or more specifically the control aspect, you can see that you have a lot more ability to accommodate these new resources. And this slide and this table is focused on these worst case conditions, but it also applies to better off feeders too. Better off feeders that can currently accommodate 1 megawatt, well, with a little bit of control, they might be able to accommodate 2 to 3. You might not have any problems within the next 10-year horizon, and those feeders no longer would be something that we need to do something about right now. Or if we do need to do something, it's just that we need to actively either manage or incentivize that those resources operate in a different manner than what might currently be happening. So one of the big nuggets and takeaways from this whole assessment was, let's look across holistically on the grid and identify where either we have to do grid reinforcement or where we can get significant advantage from just a little bit of control of the devices themselves. It's not just that we have these time-based hosting capacity curves that give us this risk for planning, risk-based planning, and also insight into management of devices. You know, as this whole session today is focused on active management of DER, these time series hosting capacity curves are also being utilized in new ways today to provide dynamic operating envelopes to give us perspective that, you know, a day ahead we might need to actively manage the devices themselves to say they need to operate within this particular window. And this is what I have highlighted here on the right-hand figure of this slide, that you can create this envelope of what the radial network or what this feeder can currently accommodate from both a generation aspect and from a demand aspect. And as long as we control these devices to operate within these controllable devices to operate within this envelope, the grid can forego any potential violations in that window of time. So another aspect of, you know, new tools to actively manage DER, you know, creating dynamic operating envelopes, giving some indication of how do we operationally manage devices to prevent violations in the real time is becoming a new area of interest to take hosting capacity analytics, bring them into really the DERMS aspect where we control devices, but the operators have the ability to give these signals out to those people to control their devices themselves. But again, tools. We're talking about tools here. How do we have developing new tools to actively manage DER? A lot of power from some hosting capacity analytics that I wanted to just enlighten with today. You know, one of the final pieces that I did want to add into my presentation was, I mentioned grid side reinforcement as well, and that's also a very important aspect. When we look at tools to do active management of devices, that is that customer side solution, but you will have feeders that nonetheless require some grid reinforcement too. And some of these WADA type studies that we're working on, these holistic wide area distribution assessments, allow us to look across the grid itself to see, well, perhaps some feeders, some of these radial networks don't even, you know, need significant customer-based control to integrate more devices. There might be simple solutions through simple grid reinforcement. Maybe it's adjusting regulators or adding a regulator or just doing a small amount of reconductoring. But that's another aspect from these wide area distribution assessments that I just like to highlight that we were looking at in the study with ESB, that sometimes there are other solutions too, that if we just have the knowledge and the capability and tools to do these wide area distribution mitigation assessments, we can also enlighten our planning and our knowledge of what the solutions might be. But we have things in our toolbox now that can look at grid side reinforcement, customer side reinforcement to give us an indication of, well, what those solutions are in the field. All right. Well, that is the final slide of mine. Before I hand it over now to Frank to give his presentation, I'll take a look in chat. If anything was dropped in there, I'll try to answer that in the best that I can, and if I have the opportunity to come back on verbally again, I will. So appreciate it, everybody. So I think Alessio.
Thank you, Matt. Thank you
Yeah.
so much for the presentation. And I'm giving the presentation to Frank. Frank, are you online?
Yes, I am. So good morning, everybody from my side. So to introduce myself personally, I'm working as a senior project manager with VDEFN. That's a section of the German Association for Electrical, Electronic and Information Technologies. I myself am in charge of the technical regulations about the German smart meter rollout and communication platforms. And for that reason, I would like to share some insights of our thinking about how to deal with smart operations for future grids. So what I would like to share with you today is first a look inside the legal framework for the smart operations of distribution networks we face today in Germany. So something about the legislation and the consequences for the energy sector of that. And of course, then the second part of my presentation will cover some key insights about the technical solutions, how we would like to answer this framework. And before I start, so if in case of any question you might have, please use the chat to ask me the question. I will try to answer instantly within my presentation, or I will reply to your message afterwards. So one step back to give an idea of who we are, what is VDE standing and VDF standing for. So VDE is a non-profit organization in Germany, one pretty old organization for innovation and technological process in Germany. You see the quite impressive figures. Who is part of our organization, and within this umbrella organization VDE FNN, the Forum for Network Technology and Network Operation is one part within this. So we are a bit special. We have a bit of special role in the German energy industry. We are dealing with the technical regulation, so that's the missing link between law and regulation settled by the government and the regulator, and industry standards on the other side of the chain. And so the application rules we are compiling for the energy industry is a bit of a mandated work on behalf of the industry and the government. And therefore we play I guess a key role in any kind of transition in the German energy industry. Well, so as I said about the legal framework, Germany is on a quite challenging road to transform its energy networks from today to the future, with nothing less but 80% of renewables integration by 2050 as a target. And maybe you have heard, so we are about to dismiss our nuclear power plants the last ones by end of this year, and currently debates to dismiss all the thermal power plants are based on coal and gas, coal especially at latest by 2038, maybe earlier, maybe not, we will see. But in having said this, with a traditional generation to be taken out of the system, and the massive growth of players with local cogeneration, renewables, and wind farms, PV farms, and on the one side, on one side, and a lot of new loads and demands by electrical vehicles and heat pumps, etc. We are doing nothing less but transforming our energy network from the traditional distribution network over high, middle to low voltage up to a peer-to-peer network with a massive exchange of energy and information on the other side about between all these players, and you may imagine the emerging complexity of this system, what is leading to some challenges in the network we are facing right now. That ends up with a simple need to make the traditional let's say a bit old-fashioned distribution networks to a really smart network, smart grids. And as a piece of history, so we are dealing in Germany. We're dealing with these targets about the energy industry since 1998, when the regulation and unbundling of the energy sector started due to the EU directives, and you see in the early stage of the century, Germany started to deal with acts about integrating renewable energies and combined heat and power. At any time, each of these acts that was implemented to the German energy sector was quite complicated and with very high sophisticated calculation and subsidy schemes for the concerned energy sources. And unfortunately to say, with any new act that came into action for Germany, nothing of the old massive regulation acts disappeared. So it's at the end, it's a bunch of a lot of complex acts about the energy industry. And finally, within the last let's say 5-6 years, we started to deal with this what everyone calls smart meter rollout. So and this means for Germany, I will come back to this later. When we are talking about smart metering infrastructure, we always talking about control of load and generation in the low voltage network based on this metering infrastructure. So let's see what makes it a bit of a challenge. So with all these different acts introduced to Germany, dealing about network control, what is the basis of any smart operation, we got some regulation on why and how to deal with renewable energy sources, about why we should deal with controllable load. As you see on the right side of the slide, there are a lot of measures taken to get technical guidelines and specifications for that, but unfortunately, until today, a missing link in the legal framework is the question of how to control all these controllable appliances in the network. Yes, we are missing this another act for Germany, but it's significant to know that as long as we has no legal framework for the network operators, on what basis they are allowed and obliged to take control measures and invest in technique for doing this, it remains as a challenge to move forward. So what makes it so? Why do we struggle with this important piece of legislation today? So if you see this kind of conflict between, as I said, between market and network, the energy market is today in Germany is pretty old-fashioned with a vast majority of fixed tariff schemes for customers. The, let's say, most high sophisticated, if I can call it like this, are some tariffs with on and off peak or light load arrangements for the consumers. So nothing at all attractive for on economical base for customers to do anything else but simply consuming the energy. And it's a lot of debates about dynamic tariff schemes for the future that requests the smartness of the technology, but on the opposite side, that but as I said, there's all this market approaches do have a more or less nationwide impact to the energy system, to the consumption, and to the demand by customers, and to the load that has to be balanced. And network operation works in a different way. So any network squeeze will appear local, simply behind one dedicated transformer station. And so the network operations today are based on very fixed rules. So we have decades-long experiences in how to run our networks, but these experiences will not work in the future because we do have new participants in the market, local generators, controllable high loads with a very high demand of load. And so you see that means at the end we have to make our network smart to handle this. And just one more to understand why this debate, why this is a conflict between market players and network operators. You can see it just by this two quotes from different players. So there's a totally different understanding on how the energy systems should be designed to satisfy the wishes of the different players. So any new player aggregator or any new market player has a true interest in unhindered and unlimited availability of power for their own customers. And opposite, the DSO business model relies on maximum and equal availability of power for all customers. So this is a conflict that has to be handled by technique. And finally, that means we need the one key thing in transforming our networks to a smart network is that we need someone who coordinates this different interests in the market. And you see that is one of our current work in this to define this market role of a coordinating entity who will coordinate and schedule all the different demands to the market. And now let's have a look to the technique of this. As I said, the basic of any smart operated network is a communication platform joining all these different players in the market. You see, when it's based on the metering infrastructure, it needs to include the customers who needs to be informed and interact, as well as the different players in generation and network operation. And that means from the technique point of view, we have 4 basic elements of this smart system. Of course, that is the metering part, electricity meter, and sooner or later, I'm talking about Germany, the gas meter that will be introduced. But the lower part, the lower 2 components are the key parts. That is a smart meter gateway, the central and secure communication hub, and the control box, or as the name says, the control part, the load control part of the system. So to let you introduce this technique, so the smart meter gateway, or the gateway, is a secured communication hub with 2 channels. So one is, it's based on a public key infrastructure with a very high security level. So it's far beyond online, from the security level. It's far beyond online banking. It's rather an intelligent service level to secure the communication about metering data and all about that. And the second one, the operational for the one for the smart operations, as a CLS proxy channel. So it's on from the design of the gateway. It's just tunneling all the different information that goes from market players to the customer's premise and customer's appliances, back and down. So it's that are on a second channel, separated from the other one. And finally, the control box as an enabler for smart operations is a one interfacing on a secure level with a smart meter gateway, and it's a link to the manageable appliances on the customer's premise. So linked to PV, to EV charging, battery storage, heat pumps, and all this stuff. And for that, it's designed to transit all the control signals, and giving the framework for local energy management systems, and whatever the customer might have to deal with, and finally get all these devices controlled on behalf of the different players in the market. And well, you can see at the end, this makes with all the different devices, that makes it a bit more than simply a metering infrastructure, as you might have in mind. It's rather an ecosystem than a smart metering system, with all this different stuff about you see the core stuff with about around the meter, the back-end integration with the GWA means Gateway Administration System, the coordinator, and the different appliances and systems on the customer side. And then to sum up, so finally, what makes it a bit complicated to be fast in transforming the system to a smart grid. The market for load control is a bit captive because it relies on the rollout of smart meters. And as you see, the finally of about 50 million metering points we expect to get in 2030 in overall Germany. If you sum all these figures here up, then you will see that there will be about 15 million of this will be mandated for a smart meter. And as a part of this 15 millions, you have only this 8.6 million meters that are dedicated to be added with this control box system. So it's quite a small portion of the from technical point of view, it's quite a small portion of the network that is eligible by law to be part of this smart operations. That's a challenge we have to face. It's given by the very special approach of Germany to adopting the smart meter rollout, and as a consequence of that, we finally have rather to deal with customer engagement than with technical issues with that. So we have to get the customers aboard for this transition, so that if in case the customer wants to be part of the system, now regardless whether or not he is an eligible customer for the smart meter rollout by law, then the customer will join this system, and we will get hopefully much more than this 8.6 millions that we can rely on by law. So thank you for your attention for that. So I think if we have if you have 1 or 2 minutes left, I could have a look on all the questions in the chat, or do you rather prefer me to answer that in the chat?
Yeah, there are some questions in the chat. I just have a quick question for you now. Just going back to the first slides from your personal point of view, and how do you see the decision from Germany to phase out from nuclear in this new historical context we are living from an energy perspective? So how it will change, and yeah, just this.
Well, I think it's pretty much my personal opinion. I think the decisions have been made in 2016 with quite a different background to make decisions, and as always, if you make a decision, whether it's a good or a bad decision you have taken, you have to live with it. And I think it will be from the point where we are today. So with the last three nuclear power plants due to be closed by end of this year, there is no way back to nuclear generation for Germany, because all the plans are straightforward to close these plants down. And if you discuss this with the operators of these plants, even they are not keen in extending the runtime of the power plants, because all their plans are now to close it. And that's part. So for that reason, that's part of the key element in how to deal with the dramatically new situation this year, is how we do it for the coal power plants and the gas power plants we have in Germany. So as I said, last year, before we got a new government, the plan was to close them all by 2038. The new government was keen in being faster with closing down coal power plants. We have to see whether the intention of the new government to close at their best wish by 2030, if it remains, or if we have to live with coal for a certain longer time in Germany.
Yeah, okay. Thank you. Great presentation. And yeah, I think there are some questions in the chat that you will reply later. So now there will be the breakout sessions. Just an introduction on this session. There will be 4 rooms in which there will be 4 moderators, all EPRI members for each room, in which they will share with you 4 questions. It will be an open discussion, so please do unmute yourself, participate in this discussion, just say what you think, and moderators will write down the main ideas and outcomes that will come from these open discussions. So these are the breakout sessions. It will last 25-30 minutes, and after which we will come back on this main presentation with the last one provided by Mario. So please, Robin, if you can start the breakout sessions, thanks. Yeah, you can see on the main, you can see on your screen. Join now. So.
I'm not seeing a link for the breakout sessions.
I'll put you in, or if you go into breakout session 3, Mark, that's where you're supposed to be.
Okay, great.
Yeah, just open breakout sessions in the top right, participants, and then join.
Oh, and participants. Okay. Got it. I'm sorry.
Okay, and if anybody else wants to join a breakout, sorry. Yeah, if anybody else wants to join a breakout, I see that we've got a couple more here. And if you haven't already been put in, all you do is click on the participants session, participants logo in the bottom right corner, breakout sessions, and then join. Or if you're having trouble, just come off mute here and I can talk you through it. Hey, Mario, I see you're back in the main room. Did something happen with your session?
Yes.
Okay. Let's see. Akko's going back there. Will you go back into breakout session 4 there?
I will try.
Okay, there was an issue with breakout session 4 for some reason. So
I still see them all pre-assigned on my side.
yeah, I think it's just emptied out. So if people want to join another room, rooms 1 and 3 have some space. Or sorry, yeah, join session 3 if you can. If you're trying to do that. Luke.
So
I'm
Eamon,
not-
thoughts on why it didn't move them? They're all automatically assigned.
It did move and then they came back in. Mario, I see some people are now. Oh no, people are bouncing in and out of breakout session 4. Can you go there?
No, I didn't have the option to join to the breakout session.
Okay.
It's not appearing in my screen.
Uh-huh. Okay, Robin, can you assign him to breakout session 4?
Let me see if I can grab this control. Okay, moved him.
Okay, great.
Okay, thank you.
Yep.
The only ones I don't see assigned to a session are myself, you, and Irene, and then Azinwa has joined us. We can move.
Okay. And if anybody wants to join a breakout session, just let me know or Robin know here, and we can move you into the group. There seems to be just a little bit of a trick to doing so. Great. Okay, I see Ricardo's gone back in. I know Akko, I think you were trying to get into a breakout session earlier. That one is open again. There's people back in there. I don't know if anybody else was trying to get in.
I only see 2 that are not assigned. Total participants is down to 36.
Yeah, that's okay. I think we're just at the turn of the hour. So. Yeah, so if you've just joined us or if you don't really know what's going on, we're in breakout sessions at the moment. You're in the main room, so you're not assigned to a breakout. If you want to be assigned to a breakout, just let us know and we can move you into a room. Hi there, folks. You're in the main room here, and as you may have guessed, the other participants have gone to breakout sessions. So if you want to move into a breakout session, just let me know. Happy to move you out there or guide you to how to do that.
People are going back to the main session. Matthew, you're muted.
Muted me on reentry. Do we want to give just a quick, 10, 30-second highlight from the breakout sessions back to the main group? I know before the meeting started, we said maybe not, but I'd be happy to say a few words from our breakout group.
Yeah, ditto.
Okay. Mark.
You want to call the order? I don't know.
Yeah,
if we-
please go, Mark. Yeah.
Yeah, all right. But we continue to pick Frank's brain and get the German situation, and Stephen Browning gave us some perspective from the UK as well. But I think really important topics around customer models and how we continue to develop those, especially considering constraints of data privacy and developing those models, the critical nature of moving quickly to develop the new planning approaches and rather than our traditional, let's, take a long time to figure this out, and the planning processes themselves being long. So the time factor being critical. We talked a little bit about obviously understanding penetration of electric vehicle charging as well as PV and DER in general, but coordination with retail providers in terms of rate structures and how that will influence demand and how that works into planning, and resilience. And we're talking a lot about climate change resilience and investments for resilience, and that involves coordination with communities and microgrids and local resilience solutions versus grid investment infrastructure. And that is an aspect that I think is very important. So there's a few things.
Thank you, Mark.
And I'll add to that. One of the central themes of our breakout was around the grid model, and trying to manage these evolving grid models that are getting more complex. At the same time, these new analytics are a lot of more black box type studies. How are these studies being performed from one tool versus another, and ultimately making a requirement to have multiple studies that are doing things very similar but in parallel to get the perspectives that really need to be utilized. So if you're utilizing some tool for doing some active management, you might want to back it up with some more traditional tools as well. So there's a lot of evolution in the tools and the analytics that aren't quite visible to the planners to really utilize. So it leads to a lot of speculation and maybe a little bit of hesitancy in utilizing those results that need to be reinforced through additional studies. So layering in, not just there's more data, tools, and analytics, but you need to do almost 2 or 3 versions of any study to get that confidence.
We're at the very end, we mentioned the topic of open source tools and maybe to enhance collaboration and new capability development in the open source world, maybe before they get those same capabilities get rolled into commercial tools, that open source aspects may have a role. And it's, folks at Aachen in Germany are leading an open source effort in this area in LF Energy, and maybe we can watch some of that.
Yes, also proceeding to the main requirement was from our group was related to the time requirement for to cover this gap, and also finding out the difference between the southern and northern Europe with the different source PV installation. And yeah, it was the main outcome we found out from our group related to these gaps. So if you have any other inputs from your groups?
Just one comment. I didn't have many people in my room, but just to complement what you said, what we discussed is the need to have power system engineers with skills on data analytics and capability to manage data. So this is very important to combine power system, the knowledge from power system engineers and people from data science. So this is very important because we'll have a lot of smart meters, large volume of data. So we need to have skills to understand what is happening in our system. So this is something very important.
Great point. Yeah. Thank you, Mario. So if we don't have any other inputs, thank you all for the breakout session, for this the constructive discussion we had, for the main ideas and outcomes we found out in this session. So now there will be the last presentation from Mario Couto. He will present the upcoming opportunities for collaboration in Europe. So Mario, you are a presenter.
Yeah. And Mario, I'd be happy to go first if that's
okay
with you, and you might have some additional follow-up slides as well. I don't know if they ended up getting dropped into this deck or not, Alessio, but let me go ahead and kind of share
sure.
two opportunities real quick. So, around data and tools, I did want to just share two things around what opportunities there are to engage EPRI in some of this. This first one that I'm showing here in this slide, and let me know if you don't see the slide that I am showing, but it's more of a grand vision of simplifying the process of creating grid models, developing grid models, connecting the underlying data repositories, utilizing really a SIM-based knowledge base of standardized information to do this verification, validation, grid model, quality tracking, and improvement, to have more of an automated approach to develop grid models, maintain grid models, and making sure that the models are as accurate as we need them for doing these advanced analytics of today and tomorrow, especially in the face of active distribution planning and active distribution management. So this is something that Pat Brown in tomorrow's session, same time tomorrow, will also give a little bit about how do we connect the dots of grid model data management and grid model development and creation and management itself. But it's something that's becoming quite important. We need trying to get to one source of knowledge and utilizing potentially SIM as a jump off point to get that a reality for distribution grid analytics. It's much more of a reality in the transmission world, but really for the distribution, and as we lag a little bit behind transmission, it's something that's becoming more important. So I wanted to just put this opportunity for engagement of how we're trying to push the industry forward with this type of procedure and framework to improving and developing grid models for doing the advanced analytics of tomorrow and today. But I'll just stop right there. The second one that I did want to mention on was what I mentioned earlier in my presentation about wide area distribution assessment, doing some more holistic type assessments, looking grid wide about, well, what can you accommodate? Hosting capacity in the past was really focused on looking at interconnection type studies, but there's a huge value proposition for doing hosting capacity assessments, for planning based assessments, for active planning. What are we capable to really integrate resources if we have knowledge about control, or if we have knowledge about planning for grid side solutions. So, any comments, find me. I think my email was somewhere in the presentation, But I'd be happy to discuss more at any point in time about these two opportunities that I always wanted to put out there. And again, I really want to point to Pat Brown's session tomorrow about grid model data management and really setting the foundation for the possibility of actively creating grid models in an automated fashion, improving upon them as the grid changes by integrating new data streams, measurement data, machine learning, artificial intelligence, all those things kind of coming together to have the capability to improve upon our grid models for all things distribution. But any questions? I know we have some time. I'll would welcome some questions here on either one of these two opportunities before I hand it back to Mario. Well, I'll hand it back to you, Mario. I'll check the chat if something gets dropped in there. But again, two areas of research that I'd love to hear more from you about.
Okay, thank you, Matthew.
Thank you, Matt. Joe, please stop sharing the screen. Thanks. Thank you. Okay, Mario, so
Okay.
you are presenter, so just going down.
Yeah, I will give you just a quick overview of some possibilities to engage and to work with HEPRI in the context of the DR integration.
Yeah, it's down. Just go past all the presentation. It's at the end.
Okay. Okay. No, I think. Yeah, I can share my screen if you prefer.
Go up. It's there. It's here. Yeah.
It's not here. Okay.
Okay. So please, you share your screen and then we will share this one again. Okay. So thank you, Mario.
So now you can you see it, right?
Yes.
Okay, so just to give a quick overview of the European context. At this moment, European Union is defining ambitious targets to decarbonize the European power systems, to achieve 40% of primary energy to be derived from renewable sources. So it is necessary to develop energy generation technology, energy transmission and distribution systems to achieve the European Green Deal vision of a fair and prosperous society. And the European Commission has identified some research and innovation actions to provide the necessary technologies and knowledge to achieve the climate targets, namely the neutrality in energy sector. And an important topic is the digitalization of the energy sector. Green digitalization of the energy system in order to support the use of user and energy-centered digital technologies based on the data exchange, data availability, and interoperability to develop new digital use cases and services to support the energy transition. So just some drivers of the European context. Of course, the decarbonization leads to the decentralization of the power system, as we have been discussing today in this session. DRs are being connected mainly to the distribution system. So the use of smart grid technologies and new solutions are expected to drastically change the distribution of electricity, requiring more active role from DSOs in managing the distribution system, incorporating demand, electric vehicles, and so on. So this is the reason because we have this project, reading DSOs for DR services. So the future objectives and functional specifications for the DSO are wide-ranging and might include enable DR participation in wholesale markets, procuring DR services to the distribution system, actively managing DR and the distribution system to provide ancillary services, for example, to the DSO. So in many cases, utilities are still working to define a strategic direction for a great integration of DR that provides services to the grid. So electric utilities are facing wide-ranging challenges, which includes DR modeling, interconnection analysis, power quality, distribution system reliability, and very important, the operational coordination with the market participants and market operators, and the coordination between transmission system operators and distribution system operators, and other topics like data management, communication, metering, and telemetry. So there are several aspects, and at the same time, we need to create a common vision for DSOs and to help and support the distribution utilities to create a plan to become an effective distribution system operator. Of course, there are different regulatory contexts over the world, but we need to work together to define this new view. So our project will have two approaches: the strategic roadmap and the tactical implementation plan. The objective of this project is to support distribution utilities in preparing to face the challenge of the DR integration, developing both strategic roadmaps and tailored implementation plan. Strategic roadmaps will identify the functions, objectives, and capabilities needed and define a conceptual plan to achieve the future needs of a DSO. This will be based on the participants' current states. So we'll try to define implementation plans, actionable steps for reading process, application systems to accommodate these visions for DSO. So the first approach, the strategic approach, will support the utilities in formalizing these future visions for DSO by identifying the capabilities needed to achieve this vision, enabling proactive planning of future scenarios with DRs, providing services through a logical progression of actionable steps that ready the systems, process, and tools. The tactical implementation will assist utilities in advancing their systems, process, and tools through implementation plans tailored to the unique needs of each utility. We intend to identify the improvements and functional requirements for high priority system components to ensure safe distribution operation when JAR start providing services to the grid. So more information about this project, feel free to contact us if you like to receive more information about this project. So EPIC plans to provide some insights through a variety of deliverables with a collaborative and individual webcast workshop with distribution utility, technical briefs describing the key implementation challenges faced by the DSOs, utility-specific roadmap to document the future goals and capabilities, current and future state system architecture diagrams. So a lot of things we need to discuss with the electric utilities. Another aspect it is very important is the grid model data management, as mentioned by Matthew some minutes ago. So this is something very important, and to create this new vision of the distribution system will be important to create accurate models for the distribution grids, because transmission and distribution grids are becoming more complex, more variable, and simulations across many time frames within and across transmission and distribution are becoming more essential to operate a grid with large amount of DRs. So network models are the crucial input to simulations. So it is important to create accurate and accessible network models. Otherwise, utilities will not be able to play their vital role in addressing the climate change. So this is something that HAPRI has a strong background. Tomorrow we'll have a session about the grid model data management, so please feel free to join. Just a final remark about the future Horizon Cluster 5 about climate, energy, and mobility. So we can identify 4 main topics. So we intend to develop, working together with academia, research institutes, IT providers, utilities, and we can identify several aspects that will be important. So in the first drafts from the Horizon Europe for the next years, we can identify the need to develop research and innovation in energy system planning and operation. For example, system approach for grid planning and upgrading support a grid with a strong component of electric vehicles using artificial intelligence. We need to keep the work. There are a lot of European projects addressing the TSO-DSO flexibility management. So this is something that Horizon Europe will continue working, to support the development of digital twin of the electric system and energy system, the reliability and resilience, the need to improve the forecasting tools to deal with high share of renewable sources connected to the power system. And finally, this is an important aspect to the distribution grids, the active consumers, markets, energy communities. So it is important to support the development of digital twin of the consumer. So this is some topics that we have in mind, and we need to continue working on these aspects. So we are looking for opportunities to work with different European partners in developing solutions for the Horizon Europe proposal. So Alessio, I finished my presentation.
Thank you very much, Mario. Wonderful presentation. Just sharing last slide. So to conclude all, as mentioned also before by Matthew and by Mario, this will be the session for the last day of the European Workshop Week tomorrow. Especially could be the grid model data management session will be relevant for the distribution perspective and in this kind of topics. You can use this QR code to register or the link event. Thank you again. You have anything to say, Matthew?
Sorry, getting off mute. No, I appreciate everyone being part of today's session. I do appreciate it, and the breakouts were, I think, a success as well. Really did appreciate all the insights that were provided through the breakouts, and hopefully y'all caught some value from the presentations that were provided as well. So looking forward to future opportunities for engagement, and reach out to us if you have any questions or ideas or concerns or things you want to do moving forward. Appreciate it, everybody. Thanks.
Thanks, everyone. It's a great
Thanks,
session.
everybody. Yep.
Everyone.
Thank you.